Hi, everyone. I'm Grace Andrews, and welcome so much to my talk. There's a lot of you. I was expecting just a couple of rows. This is more than a couple of rows, so thank you for coming. Hope all the people I told to come are here to ask me the easy questions I told them to ask me. So I'll be looking for you. This is the obligatory, oh, is it showing? Oh, you know what? I started it, but I didn't really start it. Here we go. That's what you're supposed to see. Awesome. This is the obligatory safe harbor slide. I'm not going to read it out loud as if it were story time, but you can kind of take a really quick glance and become acquainted with it. And this is me. My name is Gracie Andrews, as I mentioned before, and I'm a solutions consultant at New Relic. A question I get a lot is, what is a solutions consultant? I think that we all work in different sectors, and we have lots of job titles for lots of different, and sometimes the same thing. So what that really means is that I am a customer-facing pre-sales engineer who is really focused on helping my customer understand our product, helping them to see the vision that they have for their ecosystem, and then helping them to implement it, execute it, and maintain it, while using not just our platform and our tools, but also ecosystem products as well. So really kind of, I say, coaching them through the technology that makes them work better. I live in Portland, Oregon, which is one of the offices, and so I am not a Portland native, but if there are any Oregonians here, go Portland, keep Portland weird. And I'm passionate about a lot of things, but the top three are the people, the planet, and the tech. And I really love when I can use all three to come up with creative solutions for making the world a better place. So we're going to talk about Kubernetes today. There's a lot of stuff to say about Kubernetes, most likely because I think it's a time when being able to orchestrate large-scale and small-scale environments well is really important. But I think that before we can have a conversation about Kubernetes, we have to have a conversation about containers. And so how many people in this talk know what a container is? Awesome. Some people are not raising your hand. I don't know if it's just because you don't want to or because you don't know, but let's define a container. And a container is essentially just going to be a small piece of something. I know that's a super high level and like non-technical definition for what a container is, but what that really means is it's going to be holding any kind of platform or application. It's going to have code. It's going to have packages, anything you need to very, very concisely run something. And a lot of times when you talk about containers, you talk about smaller building blocks than when you talk about VMs. So who here is like really familiar with virtual machines? All right, so excellent. That's something that is, I think, still relevant in the world today. Don't hurt me, anybody. But it's something that is the predecessor to containers, right? We used those first before we started to say, is there a way to have smaller resources being utilized here and be able to do more with less, which is always in technology how a lot of the great advancements come to be. So that brings into account Kubernetes, right? So where containers are actually doing the work, somebody has to orchestrate them. Someone has to tell them what to do, when to do it. And that's when Kubernetes or tools like Kubernetes come into play. And what that's going to really help you do is to orchestrate and organize your containerized environment. And so today we're going to be talking about specifically how it helps you do that and why you should consider adopting some of these best practices so that you can run more efficiently, so you can scale quicker, and so you can save money. So this slide is probably my favorite slide, mostly because it's about the Kubernetes adoption journey. So what do we mean by a journey? Well, as you can see, there's a place where we all start, which is called help. I need Kubernetes. And then there's a place where we're all trying to get, which is called the promised land. I think everyone always talks about the promised land no matter where they're trying to go. So whether it's a Kubernetes journey or just a really fun road trip, you're trying to get there. And what that means for us is, how do we get to that place of a stable state? I think we hear of a lot of tips, we hear of a lot of advice, but rarely do people ever say, this is why I'm doing it this way, and this is why you should maybe think about adopting this practice. And something to also think about is how we're going to talk about Kubernetes. There's many ways to talk about containers. And I'm specifically going to be addressing containers and Kubernetes from the lens of observability. I think that that's the layer that should be on top of all of the work that we do that helps us to maintain stable environments. So today, when we talk about the 5 best practices, we're going to speak about it from the perspective of observability. So in the beginning, when I was getting ready to do this talk, I am not a Kubernetes expert. I don't know if I'm supposed to tell you that, but I'm going to tell you anyway. So when I was, selected as tribute for this talk, I thought to myself, oh my God, what am I going to do? And then I thought, I'm going to take it to the street, and by the street, I mean the internet, and I'm going to figure out exactly what the best practices are. I talk to my customers about this kind of stuff every day, but when I had to start to generalize it for a greater audience, I was having a little difficulty. So it was like top 5 best practices, top 10 best practices. And a lot of folks were saying a lot of the same stuff. So luckily, I get to join the crowd of voices that were talking about some of the same stuff. But I found that there were a few outliers that I thought were really interesting that no one was really explaining in a way that I thought made sense for how I work. So I thought, let's go ahead and maybe make that the meat of our session today. So these are the 5 best practices that I decided to utilize. And I want to take some time to give a big shout out to Sten, who is actually the previous founder of CoScaler, which was a new Relic acquisition that specializes in microservices and Kubernetes. I borrowed this talk from him, put a little grace on it, and made some modifications and changes. So I just want to take the time to say thank you. So what are the best practices and why do we have them? The 5 we're talking about today are building small container images. I'm sure I heard a collective internal duh, but we're going to talk about that a little bit more. Leveraging namespaces, setting up health checks, and using resource requests and limits as a means of utilizing multifunctional alerts. And then contextualizing the problems. And so using tools that allow for you to do so. So let's go ahead and start with our first best practice, which is build small container images. The whole point is, when it comes to containers, they're not VMs. They're not meant to be. A lot of times when people, ourselves included, and myself included, go to build a VM, I'm going to throw everything in the kitchen sink at it. I'm like, I don't know what this is going to need to do. This is exactly how much memory we need. We need all the memory in the world, all the CPU. We need to have 35 packages. There's this one package that does my taxes, got to have it on there. So it doesn't matter what it is. We end up putting a lot of resource on the system because we don't know, or we have an idea what it might end up serving a function for, but that could adapt and that could change. When it comes to containers, you don't want to use that approach, and you don't want to use that approach because it actually slows things down. More than slowing things down, it actually can create a security issue because you have more surface area where you could potentially have any kind of security gap that would make you susceptible to an attack. But the reason why you really want to use smaller images is because quicker builds mean shorter time to pull. And this is really important when you're not maybe necessarily working on some super speedy, high-speed fiber internet that might be in your office, right? A lot of us work in the wild, which is code for coffee shops or on planes or in customer offices. A lot of us work maybe from home where you might not have super effective internet. And being able to decrease the amount of time it's actually taking to render your builds is really vital. And when you have an image that's 700 megabytes versus 65, you're going to really have a different experience. And that matters because in the world of containers, if things don't load properly or come up in time, you'll be stuck in a pending state. And a pending state is sort of like the purgatory of containers, right? You don't want to be there. If you're stuck in pending states, it can really disrupt the rest of your workload. And so if you've got other pods that need to come up and are dependent on a container in a specific pod, and that never comes up, then that might mean if the pod that's managing your networking service never works, then your application may never ever be connected to your network, right? So those are little examples of how, as small and as very, I think, obvious as this might be, it's a practice that some people either don't consistently adopt, or if they do adopt it, they're not quite sure why. And it allows for you to do more with less. So these next slides are really focused on layers. A lot of times, what I just showed in the previous slide, we were using Alpine Linux, which is a smaller distro of Linux that is compatible with a lot of various frameworks and allows for you to do a lot with less because it's got fewer packages, et cetera. But something to really be mindful of is how you build. A lot of times people think, I'm going to use containers, but the question becomes, what is the function of that particular container? What is that container going to be a part of? What are the components that you need to have? What's its job? Not just simply, this is a quick way to spin up a really small app, but what's going to be the larger ecosystem vision? And by utilizing small images and then caching different layers on top of it, you're actually going to be able to literally just kind of like a Jenga game, pull out what you don't need and put back in what you do, especially if you've got that cache layer that's going to already be there as you kind of move different components of that around. So always remember to build small and use multi-stage builds when you do. This is going to be really important as you start to scale your containerized environment and as you begin to need more from what you're running. So now that we've kind of talked about that, maybe you're thinking, well, where's the observability part? So this is where observability really matters. How do you even know what state your cluster is in? Or how do you even know how you're performing overall? Do you have nodes that are not performing properly? Do you have specific pods that maybe are in a pending state? And that's when having a tool like New Relic really comes into view and into use. So I'm going to be talking a lot about New Relic because, well, that's where I work, but you can substitute this for any, hopefully, application performance and monitoring tool that you're using. If you're not using one, I recommend you use one. New Relic's pretty good, but no pressure. And so what we see here is we're seeing our cluster explorer. Let's see. It's up, but you can't see it. Any tips on what I should do? This worked just now. This, yeah. It was literally just working. Okay, well, while this is going, because it's a live demo, so something was gonna totally just fall off the wagon, and it just did. But what we're gonna see is how we demonstrate how you're performing within your environment. So the visualization that will at some point come up, unless I have to do some sort of interpretive dance of the visualization, which nobody wants, is going to go show you what someone up here does want the interpretive dance of Kubernetes. Okay, well, I'll keep that in mind for the Q&A session. So what we're going to be able to see is how we're doing by the namespace, how we're performing in regards to some of the really straightforward and basic underlying things you need to know, such as CPU, memory, and I/O. And we're also going to be able to actually filter against that and see how we're doing in accordance to namespace, how we're doing in regards to awesome. So you just have to go back to your slideshow. Okay, perfect. How we're doing in regards to some of the other really important metrics that we want to measure. So we're actually taking a look right here, and I can start to see these are all the containers running in my demonstration environment, and I can start to filter it out by what's even contained. What am I looking at that's a container, and maybe what's a virtual machine if I'm running in, or even an on-prem system. So if I'm running in a really hybridized environment, I can start to see what's true and what's false. Or maybe I want to be able to see what the actual container image name might be, or what the container image that is running might be. And you can do all that, and that's great, because what this really allows for you to do is just see that overall performance. So we see here, we've got all of these various labels and tags that are being ingested as a part of the metadata, and we can see how those processes are doing and how they're running. So here we are looking at that I/O, the CPU, and the memory. So once again, this is why having some sort of observability layer is so vital to being able to effectively understand what's happening in your environment. Which takes us right back to our next slide, which is going to be about the second best practice. So the second best practice that we have is going to be in regards to names. So names are something that are important. I think most of us have at least one. But when it comes to running in your Kubernetes environment, or just your containerized environment, something that a lot of people don't spend too much time on is worrying about the namespaces. A lot of folks will just name a specific namespace after the team that might be managing a service that's in it. So a lot of the behavior around naming is, well, the ops team manages this, so I guess that's ops A, ops B, ops E, which is great, but what happens when the operations team hands it off to another team? Maybe you're actually splintering off your operations team, and some people are going to become SREs. So what are you going to do in this vision of the world where you're not actually able to be the team that's supposed to be managing that particular namespace? And this is also really important because Docker usually creates default namespaces, right? So if you don't identify a namespace, everything ends up in default, which if you've got a larger environment, or you just want to have an organized environment, that's going to be really difficult to then figure out all these services belong under default, which is not going to be the particular best case scenario when it's time to allocate resources to particular namespaces, right? So you're going to end up with a bunch of nodes that all are a part of this cluster and that belongs into namespace that's default, and you're not going to really be able to identify who's who and where everything needs to be or go. So something to really think about is this image is kind of showing what the best practice is for a lot of people, right? Where you use the name of the service and then you leverage the environment that it's in, right? A lot of us start there. We're like, this is prod, this is dev, and then move maybe somewhere else. So maybe they'll say, so this is service A, and it's in the dev environment, this is service B, it's in the prod environment, et cetera. And then eventually, as companies get larger or teams grow, you're gonna wanna be able to separate things out. And once again, this really matters because a namespace basically operates as its own entity. And so you're going to want to be really mindful of how you leverage namespaces and why. So let's actually move on to the next slide. And let's take a look at what you can do once you have effective namespaces, right? So by isolating a namespace, you can do resource allocation, which within the context of a container and in the context of managing your containers, you really want to be mindful of what you're allocating. That's going to come up in the next few best practices because resource limits are really, really important. But we'll talk about that shortly. And then you also want to make sure it's really clear where Kubernetes is going to be deploying various pods, where it's working, because that's how the Kubernetes API is going to be leveraged here, right? If you determine the specific namespace it needs to be sending or nodes or pods into, then you're able to better effectively run in a streamlined manner. And it also just helps with overall profiling. If you have everything in its respective namespace, you can start to identify patterns in the behavior of your container. If everything is just default, default, then you don't actually know, are we experiencing a namespace issue where all of the various pods in a particular cluster, in a particular namespace, always seem to have some habitual problems, like they always are in a pending state, or maybe they're always timing out, reaching those resource limits, or is this an overall just sort of planning problem? And you're not going to be able to determine if it's a resource issue, a planning issue, or a people problem without really leveraging effectively your namespaces. And so let's actually see what that's going to look like in our world. So in the world of New Relic, this is how we would be able to demonstrate what you would be able to see in regards to namespace patterns and behavior. So let's see what they did again. Okay, so here we go. So we're back in this Kubernetes cluster, obviously, but you can see something that's happening on the left-hand side. We see here that we've got some information about this particular cluster that we're looking at. And I can see how our control plane is doing, right? So is everything green, which means it's good to go, and the scheduler and the API and the controller are all doing what they need to do. And I see that I've got a number of deployments, and I've got various namespaces here. And so there's actually a pre-created dashboard that lets us see, once again, capacity utilization, which helps us identify how we're doing and where we are. But more importantly, I want to go down here to see how the containers are that are running by particular namespaces, so we can start to see exactly what those namespaces are and what's the percentage of utilization that they're actually taking up. So once again, we can identify, do we have some sort of bloat coming from a particular namespace, which is going to be really, really useful in spinning up substantially more and scaling. You'll know where you can scale, which namespace it makes sense to scale to, and how you should scale. So that's why namespaces are really important. And we're going to build upon the idea of namespaces here. So even though it seems a little minute, it's going to become an important piece of the puzzle very shortly. So our next best practice is actually going to be dealing with particularly health checks. So how many folks here, when they're leveraging their environment, they actually use health checks? Okay, so there are a lot of people who set up health checks. And so for those who doesn't use health checks, it's okay to be honest, no one's judging. Anybody? Nobody? Everyone in here uses health checks. Well, this is like the best room in the whole wide world. Okay, so that's awesome. But specifically, the health checks that we're talking about are going to be the readiness probes and the liveliness checks. And prior to preparing for this talk, I had heard of health checks. I had, seen them even, but I hadn't really stopped to think too much into if I was using them, if I was advising my customers to use them consistently and always, and how they should use them. And so let's actually define what we mean by a readiness probe or a liveliness check. So your readiness probe is going to tell you, are you ready to go? So is everything as it needs to be so that you can execute on whatever it is that you're hoping to? And then for the liveliness probe, are you dead or are you alive, right? So is this particular pod up, running? Is it doing anything? And that's really important because it allows for you to troubleshoot faster. If you fail your readiness probes or your liveliness checks, then you know that something is going wrong, right? And it actually tells you what is going wrong and how it's going wrong. And this is really important because you can actually use these health checks to figure out what you should do next. So I borrowed some snippets of code from Kubernetes.io, so thank you so much to them for that. Their documentation is awesome. But this is an example of what a readiness probe can look like. This is a really simple example where you're executing something, right? So a particular command, which is to cat out a file. And what you're doing is you're just seeing, once again, are we ready to go and do some sort of action? Is it where it needs to be? And you'll note that there's an initial delay of 5 seconds. This is really important because if you're using readiness probes and liveliness checks together, you're going to want to make sure that you allow for that delay, because without the delay, if one starts before the other is completed, you're always going to fail. So that's just a best practice to keep in mind. And another pro tip is you can use synthetics checks to also help you better identify if your networks are clear and if you can receive and send traffic. So that's something to think about as well, is how you can start to incorporate various practices you might already have, such as leveraging synthetics tests and minions to make sure that you're performing or ready to perform like you need to. And then here is an example of that liveliness check. So here we're doing a little bit more. As you can see, we're still going to be setting that initial delay, and we're going to be wanting to wait at least 5 seconds. But if you'll notice, we're actually specifying a few things here that aren't specified previously, right? So we're going to have some namespace information here that's going to be super useful for you. And you're also, of course, specifying that it's a liveliness check. But so what? Right? So you have these health checks, but how do you actually know, unless you're either in the command line or leveraging some sort of observability tool, how you're doing with these checks? And that's, once again, how and why we want to also be mindful and leveraging something that allows for us to see how we're performing, so that we can actually be able to identify if we're passing or how often we're failing. Because a lot of times, even for people who use health checks, do you always know how often a check is failing? Raise your hand if you do. All right, so there's fewer hands going up. So almost everybody in this room is doing some sort of health check, but not everybody in this room knows how consistently those health checks fail or succeed. And once again, this is a question of how are you observing what you're doing, right? So within the context of New Relic, you can actually leverage our infrastructure product to be able to do that, right? And so once again, you don't have to use New Relic. I just suggest that you have an observable layer that allows for you to monitor and see what's going on and how it's going on. So let's take a look and see what that looks like in our world. So in our world, it's actually going to look a lot like this. So this is an events timeline that we're looking at. There's nothing up yet that's going to make you too excited. But what's really cool about this events timeline is I'm just looking at the last 24 hours of behavior in my demonstration environment. And what I want to do is I want to look for specifically either the readiness probes or the liveliness checks. So we can spell readiness, no pressure. And so when we looked up readiness, it's giving us a list of all of the events that, of course, have that. And so we can see here that we've got a bunch of readiness probes. I'm going to zoom in real close, that you can see that are failing. And they're failing in different, across different nodes, but they're also failing different checks. And so here we know what time they're failing and how they're failing. And then we can do the same thing with the liveliness, or the liveness that we're looking for. And so here's a liveness probe also telling us where we're failing and when we failed. So we have a running record of how we're doing. Are our checks effective? One could argue yes, but if you are failing, how do you know you're failing, and what do you do once you continue to fail, right? So this is a question of optimization. If the checks that are supposed to be running are not failing, then you want to go back and you want to optimize against whatever that check was, right? You want to make sure that those nodes aren't performing poorly because of a resource allocation problem. You also want to make sure that you're not stuck in some sort of pending state, which can become just a spinning wheel of perpetual nothingness. So you want to make sure that even as you're getting ready to do these checks, that you have requested the proper allocation of various resources so that you can be successful. And so that's what we really mean, too, when we go into our next best practice. So the next best practice that we're looking at is going to be focused on specifically requests and limits. So requests are going to be when you identify what the container is going to get. Once again, I bet everyone in this room probably already knew that. And then limits are your hard numbers. Don't go above this. So you can think of requests and limits as being bookend to being able to set up and run stable environments, right? So you're telling your particular container, hey, this is what you get. You're telling your particular container, hey, you can't get more than this. And that's what's really going to be helpful in making sure that you can scale quickly and that you can scale in a volume that makes sense for the resources you actually have allocated. So once again, here is an example of what you're going to be putting into your YAML in order to be able to establish those requests and those resource limits. And so this is what it looks like. But the same way in which you can do your health checks, once you've actually set these requests and limits, how do you know when they're not met? Someone can shout something out. What happens when you don't actually have enough resources? Doesn't schedule. Awesome. What else? It's like school. Okay, maybe nothing else. But we see here that you can have a lot of stuff happening, right? If you are reaching higher than your memory limit, pods can just terminate, just kind of fall over and die, right? You can, when you overuse CPU, you can throttle your various pods, and you can also just be stuck in that pending state where you never schedule. So this is actually one of the biggest problems a lot of us face, where we're like, well, I don't know what happened. I thought I had enough resources, and I mean, I passed my checks and stuff, like, right? And that's because a lot of times we don't have warnings and alerts that we have actually set up that should be accompanying whatever requests and limits that we determine are necessary for our environment. So that's why it's also really important to make sure you have an alerting workflow that's based on this. You want to be able to say, we've reached our limit, and this is what we're gonna have to now contend with, right? So that you know, if you don't have some sort of like auto scaling that's set up, if you're doing something a little bit more manual, or you're just kind of running in a very small environment, you know that you've got to either allocate more resources, or you've got to bring down unused containers that are just kind of sitting there spinning, and you want to be alerted to when to do that. And so within the context of how you can observe that, you can set alerts that let you know warnings and violations, right? Because you don't want to just be alerted when everything is on fire. No one likes that feeling. You want to be alerted when it makes sense that you still have time to be able to make a change. So that's precisely what we're going to take a look at here. So if we go here, we can see we're back in the cluster, but the reason that we're back here is because we're going to particularly take some time to look at something that's in a state of critical violation. So what we see here is there is a particular, we're dealing with a particular pod, which is our Kafka one, and we've got two different containers that are a part of this particular pod, and it seems like this container is doing just fine, running smoothly, we're not experiencing any problems. It seems to be functioning as we intend it to. But we see that on the Kafka broker, we've actually got a critical warning, and we've got a critical violation. So when we go to take a look at those critical warnings and violations, we can see that the container memory usage is far too high. And had we paid attention to that warning happened about an hour and a half before the violation, right? So if we were paying attention, we would see that warning and be able to allocate the appropriate resources, increase the memory, so that we wouldn't have any continued problems or face any issues running the scheduler. So here we can see that we need to make sure that people are being alerted to these alerts, right? So making sure that if you use OpsGenie or use VictorOps or you use email or Slack or whatever you might use as a notification channel, making sure you're getting these alerts notified to the proper folks so that you can actually begin to make good use of your resource limits and allocations and requests. And so one of our customers, News UK, something that they did is they actually used this exact same workflow. They took the requests and the limits and they set alerts against them. And then they use those alerts as a part of their workflow in order to be notified when any issues are about to arise. So also setting your warning level a little bit lower than what your threshold actually is so that you have time to fix any issues before they actually become real problems. Which actually takes us right into our next best practice, which is actually about contextualizing what's happening. I'm putting here leveraging logs, but it's not necessarily leveraging logs. It's about making sure that you're leveraging context, right? So you can gain a better understanding of what's happening, you can gain visibility, and so that you can also gain stability. And all of those things combined allow for us to reach, what we're calling that Kubernetes promised land. So why does that matter? It specifically matters because most likely, right, you have environments that are achieving something, serving a function. So how do you know when there is a problem? Let's say you have a particular container that's serving up an application. You still want to be able to know and troubleshoot within the context of that container how that application is performing, how is it doing, or maybe it's a vital service. And so if you're not monitoring that particular component that's running on that container, you're not going to actually know when there is, once again, maybe you know when there's a resource problem, but do you know when there's actually a code level problem? Do you know when there's actually an application-centered problem? And so being able to consult your logs will let you do that, right? It's one of the primary resources that we have when it's time to troubleshoot issues and really better understand what's going on and how we should go about fixing it. A lot of us consult our logs, and then we search through logs and logs and logs, and we hopefully find what the problem is. So you want to make sure that you're leveraging something contextually. And so within the context of how we recommend people do that work, right? We recommend people bring in, let's say, their EKS logs from CloudWatch, or they can bring in just the particular logs for that application or that service that might be running, and we can start to look at it and contextualize once again within the context of the Kubernetes cluster that we have been using as the main and primary resource for troubleshooting and identifying how these best practices really work. And so if we go right back where we were, which means I'm gonna have to toggle the screen. And so if we go right back into that Kubernetes cluster, what we're able to see is that we can start to look at logs within the particular application or service or whatever that container's function might be. We can start to see the logs within that context. So if we go here to see logs, hopefully something fun and useful will be generated, but we can see, we've got like process IDs, we've got particular information about what that service is, host name. We can even start to search against particular, if we would like, namespaces. This set of logs, it only pertains to the coordination namespace, but you can imagine that there could be more namespaces here that we would want to dig through. Because I selected a particular pod, that's not the case here, right? We're in a very specific container looking at its logs, but this is all useful. And so now we've got this problem-solving methodology where we see the logs in context to that particular container. And that's what the usefulness of an observability tool is really gonna let you do, right? A lot of this stuff you can do either from the command line or you can do manually, maybe leveraging, CloudWatch and going in there, seeing how you're performing against your various expectations. But being able to have a platform and a tool and a resource that does that for you is absolutely vital, because you don't want to spend all your time looking for problems. You want the tool to tell you where the problem might be. And so that's something to be very mindful of, and logs and context kinds of really bring all of that together, right? And so with our customer News UK, once again, They were able to use logs and context in regards to problem solving, and they were able to take all of the best practices that they had been implementing, right? So setting alerts, setting limits and resource requests, and then also leveraging effective namespaces that told you particularly what those containers in that namespace, what they did, what environment they belonged to, et cetera, and using really small images, they were able to then, when they had a problem, pull out the component piece that was problematic because they could start to look at all of that behind a single pane of glass. And so they were able to use the full platform solution to solve a lot of their problems. And that's really the heart of it, right? So you really want to be able to, when you implement these best practices, which are not the only best practices that exist, you want to be able to apply them in a way in which you can be consistent and apply them in a way in which you can actually help to create I don't want to say formal because you don't maybe want something too rigid, but an understandable workflow that not just your team or your particular piece of the technology can use, but ones that you can also help and provide for other teams as well. And that's what's really important about being able to observe what's happening. Maybe you want other teams that don't have access to your particular namespace to be able to see how your nodes, how your pods are performing, how the overall cluster health is, how your resource allocation is working. Because if you've got multiple namespaces that belong to different teams and you're now starting to fight for resources, there's a chance that you could be undoing the work of another team, or you could be limited in the work that you can do because they're expanding or they're kind of encroaching on resource territory that you need to get your work done, right? So being able to leverage a few of these best practices is really gonna be able to help you do that. And so to recap, since no good talk is complete without a recap at the end, we really want you to think and build small. A lot of times we think and build big, but it's really about having these bite-sized components and these bite-sized pieces that make sense for the work that we need to do. And then we want to be mindful. Names matter, so you want to be really purposeful in how you identify what you're going to name a namespace, and then you create a practice that brings that in. So once again, resource allocation on the namespace level, not just the pod or container level, right? So once again, having a big vision of how you want to execute across your environment. And then being mindful of your health. So this is a primary component to having a stable environment. Your health is truly your wealth when it comes to containers, and staying on top of any issues or any problems that might become chronic by creating a pre-problem workflow or a preventative strategy is super, super helpful. And then, of course, ring the alarm, set limits, and be able to alert against those limits, be able to be notified about those alerts, and have a game plan or a run book for what you need to be doing when things go wrong. And then, of course, last but not least, contextualize what you're doing. You want to make sure that you can find problems, you can troubleshoot quickly, that you can really cut down the amount of time it's taking you to resolve issues and problems so that you can do the important work that's needed instead of just kind of hunting for issues that might have come up. And we're here towards the end of the talk, but I want to also just kind of stress that these best practices are best used together. I think that some of us might be using 2 or 3, maybe we're using 3 or 4, but there are a number of different best practices that are really, really useful and help us better understand how we work as teams and how we work as individuals when it comes to using really dynamic environments, which a lot of our containerized environments are. So with that, I want to thank you all for your time. Thanks for bearing with some of my technical problems. And I believe we have time for a few questions.